Let's look at Rolle's theorem. If f of x is continuous on the interval from a to b, including the endpoints, and differentiable on a to b, doesn't necessarily include the endpoints, and f of a equals f of b, then there's a number c in the interval from a to b such that f prime of c equals 0. Oh my goodness, what on earth is this saying? What it's saying is that as long as you have a function that's continuous and differentiable on an interval, that's function f is differentiable and continuous on the interval from a to b, and as long as f of a equals f of b, which we have in this case, there's going to be a number c between a and b such that f prime of c equals 0. Here, for example, would be the c. That's where the derivative is 0. Now you might have actually several places where the derivative is 0. So if this is a and this is b, and f of a equals f of b, here's one place, here's another place, here's another place. Those are all places where the derivative is 0. But as long as f of a equals f of b, you're guaranteed to have at least one spot. Okay, for example, verify that f of x equals 3x squared minus 12x plus 10 satisfies the hypothesis of Rolle's theorem on the interval from 1 to 3. Then find all values of c which satisfy Rolle's theorem for f of x equals 3x squared minus 12x plus 10 on the interval from 1 to 3. Okay, so first let's verify that it satisfies the hypothesis. So we're told that f of x is continuous on the interval, it's differentiable on the interval, and f of a equals f of b. F is equal at the endpoints. So let's verify these. First, this function is continuous on the interval from 1 to 3 because it's a polynomial. Polynomials are continuous everywhere. They're not going to have any breaks in them or jumps. It's differentiable on the interval from 1 to 3 because, again, it's a polynomial. Polynomials, you can differentiate them anywhere. They're differentiable everywhere. And it turns out that f of 1 equals f of 3 equals 1. If you plug 3 and 1 into this equation, you'll find that that's the case. Okay, so it satisfies the hypothesis of Rolle's theorem. Now we're guaranteed that there's a number c in the interval from 1 to 3 such that f prime of c equals 0. Let's find that point. Okay, here's what we get using the handy-dandy program Desmos. And we're told that, okay, you can see in this diagram that f of 1 equals f of 3. They're both equal to 1. So there's got to be a point in between where f prime of c equals 0. It looks like it's at 2, but let's confirm that. Okay, so again, this is Rolle's theorem. We're guaranteed to have a point where the derivative is 0. So f of x equals 3x squared minus 12x plus 10. The derivative f prime is 6x minus 12. Let's set that equal to 0. And indeed, x equals 2 is the solution. So that's the point which satisfies Rolle's theorem on the interval from 1 to